Okay, so good morning. So today we are going to do revision for model test paper as the SPM is near. So let's dive into because now is the time not to read book, is to do more exercise until the best way is to do at least three of the book lah, at least three model set book before exam. Then I believe you will like from C will get B, B will get A. Usually it's like that lah. As usual, we will start with subjective first. Objective we do it last, okay? Objective we do it last.
Okay.
Okay. Number one, a student conducted an experiment to study the variation of leaf. Diagram one shows one of the leaf plucked from a tree. So this is a leaf plucked from a tree, okay? Measure and write down the length of the leaf.
Yeah, just measure.
Yeah, you just need to measure lah, So let me write. You just take a ruler and measure. Wait, where is my pen? Just let me take my pen. So this assuming lah, if you take a ruler and measure, it will be 5.7 cm. Assuming lah, 5.7 cm. And we look at the following question. Table 1.1 show the length in cm. Plug from the same leaf. Okay, so this is the data, tabular data. Based on the table, complete the table 1.2. So, okay, and this one will be 8. Okay, then you just calculate 1, 2, 3, 4, 5, 6. Then the total you add up should be 25 because 5 times 4, 24. So the total you add up will be 24 lah. You just calculate by yourself. So,
Yeah.
okay. Based on table 1.2, draw a histogram to show the number of leaves against the length of the leaf.
The leaf.
Yeah. So which one should I put at the x-axis? Should I put this one x-axis or this one x-axis? Number of leaf or
length of leaf is x-axis.
Length of leaf is the x-axis.
Yeah.
And this one is the
y-axis.
Yeah, okay. Because we can see that usually for science, we can see that this will be the manipulated variable and this will be the responding variable. Usually x will be the manipulated variable and y will be the responding variable. So usually we put on top lah, or towards the left. So there will be you need to take a ruler and draw. So of course I just simply draw lah. I just use this thing to draw like this. And this one. Let's use ruler lah, draw it nicely.
Yeah.
And we need to calculate the ratio. So length of leaf, so that is total of 6.0. So you here got 1 box, 2 box, 3, 4, 5, 6. So there's a 6 box. So remember when you do this, you need to put 1.0. Because why I want to put 1.0? So it will be 1.0, 2.0, 3.0, 4.0, 5.0, 6.0, and 7.0. I know that there is no reason like why you want to put that, but it shows something when mathematics, but you just do lah. It shows that you are getting your measurement in terms of 1 decimal point. So it could be you will get this wrong if you just put this 1, 2, 3, 4, 5, 6 because why you want to do that? Because it shows that you are doing in terms of 1 decimal point and you are following the question. And okay, then y-axis will be the number of leaf. Number of leaf is maximum is 10. So 1 box, 2 box, 3 box, 4 box, 5 box, 6 box. So maybe I put 2, 4, 6, 8, 10. Yeah. So I just put 2, 4, 6, 8, 10. Okay, so of course these boxes the length must be the same lah. Okay, 6, 10, 8. Okay, 6, 10, 8. So the 6 will be at 6 0.0 to 2.0. So 6 will be around here. 6, and then the next one will be 10. If I tabulate the data, 6, 10, 8, is it? Is it 8? Yeah, 8.
Yeah.
So just put it 8, and I just draw it. So this table lack of what thing? One more thing that is lacking. What is it? Is this table completed?
No.
Yeah, what is
I
it
need to
lacking?
label what is y-axis and x-axis.
Yeah, label number of leaf. Okay, so I just put here number of leaf. Number of leaf. Leaves. Plural lah. Okay. And this one is the length of leaf. Length of leaf singular, but doesn't really matter lah. But I just want to. Is this correct? Is it completed?
Need to share.
Yeah, I mean, is this thing completed already? The graph.
Yeah.
Yeah, but still lack of 1 mark actually.
I mean.
Yeah, lack of 1 mark actually. Yes, okay, you need to write the CM. Make sure you got the unit properly, huh? If not, it can be meter, it can be kilometer. So what we thought it can be millimeter. So the data doesn't show a good picture. So not only you need to put it properly, draw properly, write the title properly, and remember to write the unit. Of course, here don't have unit lah, huh? Because there is a number of leaf. But if not, then remember to write. If not, wasted. Wasted. You will get 2 mark. You will get just 1 mark. Based on the graph drawn in 1C, so this is 1C. State the type of variation. So what type of variation is this? Continuous variation. What does it mean by continuous variation?
Means it's not passed down.
It's not passed down. Okay.
Yeah.
Yeah, it means that the variation does not really show it does not show a very distinct Tinous. Okay, it does not show a really distinct feature in terms of variation. Like, can you give me example of discontinuous variation?
Discontinuous
Discontinuous.
Blood group.
Blood group. Okay, for example, blood group. Because blood group is discontinuous. For example, your graph will be something like this. When discontinuous, there will be it's a very distinct variation. 1 up, 1 down, 1 up, 1 down, 1 up, 1 down. Okay, so there is really no clear the clear way to, I mean, the data is not really clear. There is no set of data. But when we are talking about continuous variation, usually the data is something like this. The data is something like this. Go up, go down, and it is it's very clear. For example, can you give me example of continuous variation?
Height.
Height. Okay, for example, height. And let's say we put weight. Okay, so let's say this is so let's say this is the height, this is the age. So everyone height will grow up at a certain extent, then maybe down a bit, something like this. But it is the same towards the whole population. And also, let's say I do weight, the graph also, there's a similar thing that you can see in the graph where you can use this to it's almost similar lah, huh? But the discontinuous, you cannot do. It is very like up and down, up and down. That's why they say it's discontinuous. One is continuous variation. But is both data accurate? Yes, both data is accurate to represent the sample. It's just that the what it shows and what does it mean will be different. Number 2, diagram 2.1 and diagram 2.2 show an experiment to measure the focal length of 2 convex lens. Okay, so this will be the convex lens. Okay, measure and write down the focal length of diagram 2.2. So you need to use the ruler to measure the focal length. 2.2.
Actually, how to measure it? I forgot already about this topic.
measure and write down the focal length. So focal length means what? Here, luckily they already give you, this is focal length 3.6.
Okay, 3.6.
This one 2.2. There's a question mark here.
Oh,
So, very good. Okay, the answer is 7.2. Unit
CM.
cm, yeah. So a lot of students will lost mark at this place because they will just leave it 7.2. They thought they get it correct, but the examiner will give it wrong. Like mathematics when you're talking about 7.2, are we talking that about km, kilo, or meter or hour, 7.2 hours, 7.2 minutes? So the student won't get any mark. So usually it is sometimes it is the easy question that student don't get mark because of maybe
The
they are not
unit.
careful. Yeah.
Okay.
And yeah, so this is 7.2. Even if this is 7, even this is 7 cm, remember to put it 7.0 cm. Even if this is 7, again, what does it mean? It means that you are giving the answer in terms of one decimal less, because we know that the answer will show is 7.0. Assume it's 7.0 because here already 3.6. It cannot be here 3.6 and then here 7. It must be here. If here one decimal point, the answer here must be one decimal point. But 7.2 cm, okay, it should be correct. Based on diagram 2.1 and diagram 2.2, state the observation regarding the focal length. So what observation that you can see as you compare these two?
Hey, shorter.
Yeah, shorter. Okay, so the focal length of diagram, 2.1 is shorter than the focal length of diagram 2.2. Okay, so just write down very fast on here. Okay, the focal length of 2.2 is shorter than focal length 2.1. Easy, not that difficult also lah. I think this question is a bit easy. State one inference in this question. What is the inference for this question?
Thicker than the convex lens in diagram 2.2.
Correct. Okay, the focal length of diagram 2.1 is thicker than the focal length of diagram 2.2. Where is my pen? The focal length of diagram 2.1 is thicker than diagram 2.2. What does it mean by inference? Reason, state one reason for this experiment. No. Something like hypothesis, very good. Okay, something that you discover that if this experiment, we want to see the purpose of the experiment. The purpose of the experiment is to measure the focal length. So we just want to measure the focal length. And inference is something that throughout the experiment we again get something out of it, that we know our finding, that we can test it.
Okay.
With the further information. For example, the thickness of the focal length. So maybe the next experiment I want to do is, the thicker the lens, the shorter the focal length, the thinner the lens, the longer the focal length. This is maybe some next experiment that we can do, but it's not really related to the experiment, but you can do it in the next experiment if you want. So yes, it's something like the hypothesis. State the manipulated variable in this experiment.
Manipulated, thickness of lens.
Thickness of lens, very good. Thickness of lens. Name an optical instrument that uses the lens. Name the optical instrument that uses the lens used in this experiment. Okay.
Yeah.
Magnifying glass. Very good. Magnifying glass. Okay. Diagram 3 shows an experiment to study the effect of temperature on the growth of bacteria. So there's of course we want to, what you want to test obviously is the temperature towards the growth. So we can roughly think that the hypothesis would be if the temperature increase there will be more growth, less temperature then there will be maybe a lesser growth. So 5 Celsius, 37 Celsius and 70 Celsius. So which is the bacteria grow the most?
37 Celsius.
Yeah, 37. Okay, 37 Celsius will be the most. 37 Celsius is also the human body temperature. The optimum human body temperature is 36.7, somewhere that the bacteria like to live. After 2 days, the number of bacteria colony in each petri dish is observed. The result is recorded as table 2. Table 2. A few colony, many colony, and here no colonies. Okay, the bacteria. Oh, why like very easy one all the question. Okay, okay, so what is the manipulated variable?
Temperature.
Temperature. Responding variable?
Number of bacteria colonies.
Number of bacteria colony. Okay, this one usually this is x, this is y. X is will be the manipulated, y be responding number of bacteria colony. Okay, number of bacteria colonies. State the hypothesis of this experiment.
The higher the temperature, the lesser the number of bacteria colonies.
Yeah. But we cannot say that because the higher the temperature, then there is no colony actually. So what we can say for this hypothesis?
Bacteria cannot grow at 70 degrees Celsius.
Bacteria cannot grow at 70 Celsius. How about them? But how about this then?
Then
maybe you can say something about this.
Okay. 37 degrees Celsius is the optimum temperature for bacterial growth.
Okay, the 37 Celsius is the optimal temperature for bacteria to grow. Okay, yeah, 37 Celsius is the optimal temperature for bacteria to grow. What is the inference for this experiment? When you do this experiment, what is the inference? Okay, you say bacteria cannot survive in high temperature. Yes, actually inference there could be a few. That's why sometimes I always feel inference the hardest question, because when we talk about inference, it means your findings that your new hypothesis that you can in your finding. So I think one of the hardest question is this one, because inference actually, I think to be fair enough, there is a few inference. When we read the question, there is always a few inference, because maybe there's a few inference, like I can say that 70 Celsius is not a good temperature for the bacteria to live, and 5 Celsius is also 70 and 5 Celsius is not. Or you can say maybe inference too high temperature which is above than 37, but this one didn't say. If they got graph then it's good but we can roughly say that if the temperature is too high, there will be no bacterial growth, or if the temperature is too cold, near towards 0 Celsius, there will be no bacteria. They just say towards boiling point and towards the freezing point. And but the answer in the book is stated that the stated here, bacteria reproduce actively at 37 Celsius. Okay, bacteria reproduce actively at 37 Celsius. So usually I will still give correct, because I'm not sure whether the teacher in the school is very strict. So sometimes when they are very strict, they will just follow the marking scheme. So when they follow the marking scheme, they will, whatever answer you say, they will give you wrong. But I don't think this is the correct way The correct way is whatever inference throughout the experiment, it can be considered correct. So I'm not sure, but depend on your luck. But fair to you also lah, because if you're wrong, then many other students also will be wrong. So this is something, but we will try our best to write the obvious one. Of course, the obvious one is the 37 temperature is one of the best temperature for bacteria to grow. So it's different thing even though here is 37, here is 37, it doesn't mean the same thing, because here say that 37 is the optimal temperature, and the another finding is the 37 is bacteria grow the fastest, or you can even say this 70 Celsius and 5 Celsius, but don't leave it empty lah. Just try your best. I will give
can I rewrite this right for the inverse right? Can I rewrite the same as hypothesis?
Cannot.
Right?
Yeah, because when you rewrite, it won't be called as inference. It will be called as hypothesis. What do you mean by inference? Inference means something that you know throughout the experiment that can be tested in the future. So there is they reproduce bacteria reproduce best at 37, because this is the first one we say that 37 is the optimal temperature. Optimal means everything is good, is the best, but this one is 37 is it will reproduce the best growth. So that is a slightly different. Okay, because optimal could be 38, 39. This one is reproduce the best in 37. It could be 37.6, 37.2. But also a bit similar. Anyway, next question. Okay, based on the experiment, state the operational definition for bacteria. What does it mean by operational definition? Very good. So your teacher say that you need to write something about manipulated and the responding variable. I think that is also good, but actually what it means by operational definition is because if you find dictionary, you will find the terms of bacteria. Let's say my bacteria is a microorganism, bacteria is whatever thing lah, whatever something else. But when we talk about operation definition, means what are the definition that we use in this experiment, or what are the definition that we found out from this experiment, because they say based on this experiment. So based from this experiment, we found out that bacteria reproduce the best. Bacteria is an organism that produce white spot at the best at 37 Celsius. This is what we get from the experiment. That's why the teacher say you write something relate back to the experiment is something. But this one sometimes it can be above and below. Above is something else, below is you start to find out. If you above here means you haven't find out. Okay, so it could be carrying out the different meaning. Okay, based on the operation of the bacteria. Okay, so bacteria is a microorganism. Let's look back at the responding variation that spread white spot, and grow the best, if you want to write, and grow the best at optimal temperature, which is 37 Celsius. Okay, so this will be the definition that we get from the experiment, and it could be right, it could be wrong, because it could be 37.3, 7.2, 37.0, and it also could mean that for this type of bacteria, here didn't say, but it will be better if they got the name of bacteria, then you stated, because not all bacteria is at the grow the best at 37 Celsius. So maybe one day you go to university, then you can do. Diagram 4 show an experiment to study the resistance toward rusting of alloy and pure metal. So what is alloy and what is pure metal?
Alloy is a mixture of pure metal.
Okay, and pure metal, of course, is just so which one will rust faster?
Pure metal.
Yeah, pure metal will rust faster. You alloy. Can you give example of alloy?
Copper.
Copper. Alloy or
Stainless steel.
stainless steel. In the book also
Uh,
got stainless steel, is it?
yeah.
Oh, okay. Alloy, stainless steel, duralumin,
Uh,
titanium, and so on. Okay.
Bronze.
Bronze, yeah. Okay,
Yeah.
so this is the alloy and pure metal. So of course, alloy is better than pure metal. Why is it alloy better than pure metal?
Because alloy has a higher resistance to corrosion.
Yeah, because alloy has a why it has a higher resistance to corrosion.
Because it's a mixture of pure metal.
Yeah, it's a mixture of metal, and the mixture of metal prevent the molecule from
Yeah.
sliding from one another, and it makes the alloy stronger, more resistant, and
Mm.
stronger. Okay, so this is alloy. Of course, they use salt. You don't want to use salt also can, huh? Why they want to use salt?
Make it rust faster.
Yeah, make it rust faster. Okay, we don't have time to wait it, so probably we put salt, and you know that salt is actually in the series of reactivity series. We know that sodium is
Mm. Mm.
quite high, so
Yeah.
the high reactive metal will kick out the lesser one, so it will make the reaction faster. So how many days he want? 2 days. Okay, 2 days maybe you can see already the result. Okay, observe the condition of both nail. After 2 days, write the type of nail in the box provided. So
Type of nail.
yeah, type of nail. Rust and not
Rusty
rust.
is iron nail.
Rusty is the iron nail. Okay.
Not rusty is steel nails.
Okay, so this will be the steel. This will be the iron. So of course the iron will rust faster. Okay, so this one will be the
Yeah.
iron. Where iron is a pure metal, and this one will be a steel. Okay, a mixture of the pure metal. State one inference on the observation of 4A1. Okay, steel nail does not rust. Steel nail does not rust. Very good. State a constant variable in this experiment. What do you mean by constant variable?
Variable that doesn't change.
Something that's why you want to put a constant variable?
To make the experiment even.
Even, yes. No, or that's why we sometimes use the word control variable, because we want to
Yeah.
make sure there is no variable that influence the experiment. If not, it will interfere with the hypothesis, and whatever you test, it just doesn't really matter anymore, because you didn't control the experiment. Instead of testing dependent and independent variable, there is so many variables that it doesn't really make sense anymore, so we want to control it. So what is the control variable for this experiment?
pH level of the water.
pH water of the water. pH. Yeah. Okay. You can a few more. Someone got what? pH
Type
value.
of water.
Type of water. Okay. Type of water. Type of water. Maybe
Liquid. Type of liquid.
type of liquid. Okay. Type of liquid. Type of water. Volume. It should be okay lah.
Volume.
Enough lah.
Yeah. Okay.
pH value. Type of water. Volume. A steel nail is an alloy. State the operational definition of an alloy.
Alloy
Mm-hmm.
is a material
Mm-hmm.
that is highly resistant to corrosion.
Very good. Okay. Steel is a what?
Material
Is a material
that
that
is
What you say? Steel is a material
Material that is highly resistant
that is highly resistant
to corrosion.
to corrosion. Yes. Okay. So very good. Tick correct in the box below provided the substance which can replace the steel nail. What are the substance that to replace steel nail?
Steel nail. Bronze.
Bronze. Yes, very good. Okay, because bronze is an alloy, and this one will be the what?
Pure metal.
Yeah. Oh, I think maybe section B is harder a bit. So we are going to take a short break, 5 minutes, and I see you 9:15. Okay.
Okay.
Okay, see you 9:15.